Okay, here's another factoring type of quadratic looking sine function equation. And again, you should be able to see that this looks exactly like this. And to solve a quadratic, again, what we typically do is, I need to get out of that, sorry, get a little thicker, is I need to factor it. So I would do 2x and x. And then I might try, say, putting my 3 here and my 1 here, but that would give me 6 and 1, and some people might be excited and say, woohoo, I can get a -5. But the problem is this is positive, so I know that both of these are going to be negative. And so if they're both negative, a -6x and a -1x is a -7x. So right away, I can tell that that is not going to work. So when I factor, I'm going to put the 3 over here and the 1 over here. Now I get 2 and 3. Well, if they're both negative, then when I do FOIL, outside is a -2, inside is a -3 equals 0. And awesome, I found my factor. So again, kind of the similar thought process over here. I have 2 sine of theta. I have sine of theta. And my goal is to get a 5 there. So if I put a 3 and a 1, when I do this one and this one, negative, negative, I end up getting what I want. All right, so just like over here, you'd set each piece to 0 and solve. I'm going to set each part of these to 0. Let's see what I have. -3 equals 0. I'm going to bring that, add 3 to both sides, so that becomes a +3, and divide both sides by 2. So sine of theta equals 3/2. And then I'm going to go ahead and solve this too. So sine of theta -1 equals 0. Sine of theta equals 1. All right, so at this point, I want to, I've isolated my function, and so I want to use the inverse function to both sides. All right, so here those cancel, and I end up getting theta equals inverse sine of 3/2. Here, those cancel, and I end up getting theta equals sine inverse sine of 1. All right, so let's look at these. Now, if you do this on a graphing calculator, right away it'll give you, I believe, like a domain error or something like that. It's going to give you an error. Probably a normal calculator would probably give you an error message too, but a TI will say domain error. The issue is this sine function, the original, right? Theta, there's infinite many possibilities. That's awesome. But my range is -1 to 1, right? Because the amplitude from a sine function is -1 to 1. So here, when I do the inverse function, remember your domain becomes your range becomes your domain. So this is my ratio. And so for the sine function, that would have to be your inverse sine function. This has to be between -1 and 1. All right. And so if you do this, you're going to get an error, which basically means that there's no solutions that are from that. It's undefined there. So that's not going to do anything for me. So then if I look at this one, right up there is my point, which is 0, 1. All right. So this is at pi/2 in the unit circle. So theta equals pi/2 plus 2k pi, which is, again, every rotation around that positive, every rotation around that negative, where k is an integer. Now, again, if I limit my domain to say, I don't know, 0 to 2 pi, then I would just sub in 0 here, and my solution set would be pi/2. If I went from, say, 0 to 4 pi, then 0 would work, and if I subbed in 1, I could add 2 pi to that and get another answer, and so forth. So it kind of depends on if I limit the angles or if I don't limit it. So if I limit it, this is my exact answer. If I don't limit it, then I would give it the formula, and that would give me infinite many answers.